Here we go, geometry kids. Today we're going to look at 5-4, medians, and altitudes. Okay? First question we got to answer is, what is a median? You may have heard median before. Median usually means middle, right? So a median of a triangle is a segment from an angle, a vertex, to the midpoint, the middle of the other side. That's a median. Median. So if I want to, I take this point, draw a line so that it hits in the middle. Draw a line so it hits in the middle. Oh, look, they cross. They're concurrent. By the way, did you guys hear about the rose that rode its bike to school? Do you know what got there? By pushing its pedals. What do I think about that? Some botany humor. Concurrency of medians theorem says if you draw your medians in, each segment, each longer segment is 2/3 of the whole thing. Okay? So that means that's a third. For example, if DJ equals 9, then DC will equal 2/3 of 9, which is 6. And CJ will equal 1/3 of 9, which is 3. Okay? 3, 6, whole thing's 9. Okay? And that middle point is called the centroid. Okay, not in center, not certain. It's centroid. Take a moment, breathe this on. A lot of stuff. Whew. Okay, so again, the medians, that centroid is 2/3 the way across a median. And the diagram for problem 1, ZA equals 9. What was the length of ZZ? I knew I picked a bad example. So again, ZC equals 9. So ZA equals 9, right? Okay. So that means you set up the equation 2/3 ZC equals ZA, right? And ZA equals 9. So 2/3 ZC equals 9. Now, how do you get rid of 2/3? You multiply by 3/2, right? So ZC equals 9 times 3, 27 over 2. Which, if you want to make that into a decimal, would be about 13.5. Okay? B. Now what's the ratio of ZA to AC? Now, we said this is 2/3, right? And this is 1/3. So our ratio would be 2/3 to 1/3. But now you can't have fractions in a ratio. So what can we multiply both these by? What about 3? So you get 2 to 1 is that ratio. Okay? Sorry about looking around. Oh man, a lot of reading, writing, arithmetic, 3 R's, now spelling right. Altitude of triangle means you go from a vertex perpendicular to the other side. Not perpendicular bisector, because that's called, well, the perpendicular bisector. Sorry guys, moving around the chair. Okay, and where they meet is called the orthocenter. And the orthocenter can be inside or outside the triangle. Same as before with that perpendicular bisector, if the acute triangle is inside, right triangle is on the triangle, obtuse triangle is going to be outside the triangle. Okay? You guys have probably seen altitudes before. Let's draw a quick one. So on this one, if I were to draw an altitude, I'd just go here, straight down, perpendicular, here, perpendicular, right? Here, perpendicular. So that would be my orthocenter. You can tell this is a acute triangle because wall's inside. Okay, so 4 big things to know. You have your orthocenter, circumcenter, incenter, centroid. Think that's going to be a vocab quiz? I do. Okay, an ABC. Name if it's a median, altitude, or neither. First, let's look at AD. Well, AD starts at vertex, and D is halfway between C and B. So that would be a median. Why? Because it goes from vertex to midpoint of opposite side. Next, let's look at EG. EG doesn't start at a vertex, so that means it's not a median, not an altitude, it's neither. Does not start at vertex. Okay, and last, CF, we started at a vertex, end up perpendicular, so that is an altitude. Because it goes from vertex to perpendicular to opposite side. What's an altituder? Just altitude. It has the attitude to be an altitude. Because it has the right attitude, right angle to be an altitude. I'm sorry. Print. Wrong button, guys. We have a triangle with vertices. Got to find the orthocenter. Let's find some graph paper again. Here's some graph paper. Watch this. You're going to be a whole part of this process. Okay. So we have the point 1, 2. That's D. 1, 6. That's E. And 4, 2. That's F. Okay. And we connect the lines. Okay. Now, to make an orthocenter, we need altitudes, right? Guess what? This is where it gets really tricky. See this right here? Start at a vertex, make it perpendicular to it. Oh, it's right there. Start at a point, go perpendicular. Oh, it's right there. Our orthocenter is point D. Equals D, which equals 1, 2. Those right angles, those altitudes are built in with a right triangle. They're already there. It's going to be at the right angle because that's the right angle. Because you have two. You have your perpendicular through vertex, perpendicular through vertex. Okay, quick review, guys. Make sure you look at this before a quiz. Perpendicular bisectors, circumcenter, don't go through a vertex, midpoint of the line, right angle. Angle bisectors go a vertex, cut the angle in half, makes the incenter. Medians, start at a vertex, cut the opposite side in half, very close to an incenter, but not that. Centroid. Altitude, start at the vertex, right angle to the base. Orthocenter. Keep that in mind, guys, Concurrency of perpendicular bisectors circumcenter. Concurrency of angle bisectors in center. Concurrency of medians centroid. Concurrency of altitudes orthocenter. We already had this. We're done. Enjoy.